Hello friends, welcome back to your UPSC. Today in Geography of India, we are going to start with a new topic, that is non-conventional sources of energy in India. So let's get started. Non-conventional energy sources are basically renewable energy sources which are environmental friendly. They are abundant in nature as compared to the conventional energy sources which are limited in nature. They are renewable and they are sustainable source of energy, and hence they are best alternative for the conventional sources of energy for the coming generation. See, the non-conventional source of energy, it is capable of solving various problem of the demand of people or various problem in energy sector. The main problems that it is solving is, first is, it is decentralizing the energy supply. Okay, so the source of energy supply, if we develop our non-conventional energy sources, the source of energy supply will be decentralized. Like, we will not be based only on these conventional energy sources like coal, petroleum, etc. So we are our usage or our source of energy supply will be differentiated or will be decentralized and would be diverted towards other sources like non-conventional energy sources like solar energy, wind energy, etc., etc. Next, because as we all know that these conventional sources of energy, they actually they they give out or they emit pollutants. Okay, so the pollutants, they are not environmental friendly. But if on the other hand we will see the non-conventional energy sources, they are more environmental friendly and they are clean fuels. Okay, like we have solar energy, then we have wind energy, etc. So these are clean energy sources. Okay, so they help in sustaining clear and clean environment. Okay, so hence they are environmental friendly as well. Now, there are various department of non-conventional energy sources in India. So we basically have two departments as the major one. First one is was established in 1982. See, the importance of renewable energy was recognized in our country in like early 1970s. So in 1970s only we had started we had realized the importance of the non-conventional energy sources. Okay, now in 1982 we established a department known as Department of Non-Conventional Energy Source, which was renamed as the Ministry of Non-Conventional Energy Source, that is MNES, in 1992. Okay, so this department was one of the department for non-conventional energy source or non-conventional energy, including the Indian Renewable Energy Development Agency, that is IREDA. IREDA was established in 1987 and it was renamed as Ministry of New Renewable Energy in later years. Okay, so MNRE is the most popular one in the non-conventional energy sources, ministry in the non-conventional energy sources. So this is Ministry of New and Renewable Energy. Okay, so was this department, that is IREDA, was renamed as MNRE in later years. And these ministry, as we all know and we study, they have taken several steps for creating a suitable environment for harnessing these non-conventional sources of energy. And India, as we know today, is one of the largest programs has one of the largest programs for renewable energy. Okay, so the activities in these ministries, they cover all the major renewable energy sources, like we have biogas, we have solar energy, wind energy, tidal energy, biomass energy. So all these energies are covered. Okay, and then most of the energies, several energies, are systemed and they are devised for commercial availability. Okay, so they are made in such a way, or they are then extracted in such a way that they are meant for commercial use afterwards. The major renewable energy sources or non-conventional energy sources, if we see, are solar energy. It is the most prominent one. Then we have wind energy, tidal energy, biomass, biogas energy, and we have other energy sources as well. Now, if we talk about the energy potential, that is non-conventional energy potential of India, it is approximately 1,95,000 megawatt. Okay, so this potential is quite high, and if we are capable of utilizing the whole potential, then India would not require or would not depend on any conventional energy for its power. Okay, so for power generation, we won't depend on any conventional sources of energy and other sources of energy if we utilize the whole potential. Okay, now if we rank the total potential in India, the highest potential is in solar energy, that is 31%. Then after that, we have ocean thermal energy, which is 30%. Then we have biofuel, which stands on 26%. And lastly, we have wind energy, which accounts for 13% of the potential non-conventional energy source. Okay, and recently the government has made various programs for the development of these non-conventional energy sources on faster pace. So from 2004 to 14, the installation of renewable energy for electricity, it has grown at an annual rate of 25%, which is quite high. And we have reached up to 30,000 megawatt. If we look at the index of January 2014, we have reached up to 30,000 megawatt, but we have long way to go. So this is how we are just increasing our potential in this non-conventional energy area. Okay, now we will talk about the solar energy first. So solar energy, as we all know, the sun is the major source of energy, and it is in fact the source of all energy on the earth. Okay, so it is direct or indirect source of all the energy that we have on earth, is directly or indirectly coming from solar energy, or sorry, sun. Okay, so this is the most potent one. Okay, so the solar energy has the most potential, and as we can locate India, it is in the tropical region. India being in a tropical region, or it is a tropical country, so it endures a plenty of solar energy. Okay, so we have quite a good amount of solar energy, and the amount of solar energy we receive as compared to other countries that are temperate countries, we have quite high amount. And if we look at the statics, we receive about 3000 hours of sunlight every year. Okay, and 3000 hours of sunlight means 50,000 trillion kilowatt per hour. Okay, kilowatt hour. So we have about 50,000 trillion kilowatt hour energy, and this amount is more than the country's total consumption. So we can see how much the energy, solar energy, accounts. Okay, now if we look at the ways of using the solar radiation, so the solar radiation energy, it can be used through two ways. That is, first one is thermal route, and the second one is photovoltaic route. Okay, so thermal route, in it we require to heat up something. Okay, so here we use solar energy to heat up, and then this heat, it actually generates energy. Okay, but in photovoltaic route, we actually directly charge the cells, and with that we can just generate the electricity. Okay, now solar thermal energy. So the solar thermal energy, if we see, it requires a lot of sunlight, and India being soaked in abundance of sunlight, we have huge potential of converting the solar energy into thermal energy. Okay, so there are various techniques that are developed by solar thermal technique. Okay, so the solar thermal technology, we have various solar thermal technology, and these thermal technologies, they include solar water heater, solar cooker, solar heater, solar distillation system, and others. Okay, so we have many. Now, research and development in the field of solar thermal energy, it is continuously being persuaded in the country for about 4 decades, and as a result, we have several products that are being developed indigenously. Okay, so the government of India has worked a lot in this line, and because of it, we have several indigenous products that are developed in India as well. Okay, in India only. So we have several indigenous products that are developed. Now, the government is trying to promote these products by giving subsidies on in these things, on these technology, and on this basis, the government of India has launched thermal programs. Okay, so the main objective of thermal energy programs, it is first is market development. So we have to develop a market for these thermal energy goods. Okay, so the thermal energy program, it is first trying to develop a market for it, and because of it, the government is giving subsidies, government is helping the people so that they get attracted towards this thermal energy. Okay, and with this, we will develop a market for it, which will give financial support and financial benefit to this program. Next is commercialization and utilization of thermal system, and after that we have use of thermal energy for domestic, industrial, as well as institutional purpose. So we actually, the government actually wants the commercialization and utilization of thermal energy, and the utilization should not only be confined to these major these big sectors, but it should also be used in for domestic purpose. So the every nook and corner of the country should be covered. This is the major objective of the thermal energy program, that every area or every corner of the country, it should be covered in it. So it should be used for domestic purpose, industrial purpose, as well as institutional purpose. Now, if you look at the 5 components of the thermal energy program, we have solar thermal extension program, then we have solar cooker program, solar building program, research and development program, and lastly we have Aditya solar shops, which are selling these goods to the people. Now, the main technologies that are supported by Ministry of Non-Conventional Energy Sources, these are solar water heater, we have solar air heater and solar dryer, then we have solar cooker, then lastly we have solar photovoltaic cells or solar photovoltaic. Okay, so the first technology that we have is solar water heater. Solar water heater. Now, this solar water heater, it is a main technology that is supported by Ministry of Non-Conventional Energy Sources. In it, the water heating technology is mainly based on flat plate collector, which absorbs the solar radiation and it raises the water temperature. Okay, so we have actually the solar radiations, they are collected and absorbed. Okay, so they absorb the solar radiation, and after that these solar radiations, they are used to rise the temperature of water. So the temperature of water, it rises up to 80 degrees Celsius, which is quite a good amount. Okay, now this water heater, these water heaters, they are used for domestic purpose and other purposes, like they are used in hostels, they are used in hotels, homes, restaurants, and hospitals, etc. So they are used in various areas, and they are like, they pay back their investment in 3 to 6 years, depending on the fuel that is substituted. Okay, and they are, after installation, they are like almost free of cost. They give services for many years. So we have solar water heater. It actually saves a lot of electricity, and it suppresses, or we can say it contributes in reduction of the peak demand for electricity during the winter times. Okay, so in the winter times we all need some warm water for bathing and domestic purposes. So the water heater, it is used for solar water heater. It actually cut off the utilization of electricity in these purpose. Okay, then next we have solar air heater and dryer. Solar air heater and dryer, it is used both in industries as well as agricultural purposes for drying and heating. Okay, so it is mainly used in food processing industries, tea industries, dal mills, spice manufacturers. They use it. Solar heaters, we can also see its usage in cold regions. So the solar heater, it is also used in cold areas of the country, and it also helps in saving a lot of energy. Next we have is solar cooker. Solar cooker, it is a simple device. We can see it is a box like structure. So it is a simple device, and in it we actually place some containers, and the food is cooked with the help of solar energy. So the solar energy, it is used for cooking the food. Hence the conventional fuel that are being used up till now, they are saved to a significant extent. Okay, so on a clear sunny day we can cook both the food for noon as well as evening. So the food for both the time can be cooked easily in sunny days. We actually have two types of technologies in solar cooker. First is box solar cooker, and then another one is concentration type. Okay, we can also call it concentrating type. Now box solar cooker, it cooks the meal for family of 4 to 5 members, and it saves 3 to 4 LPG cylinders in a year of when we use it fully. So it saves 3 to 4 cylinders per year. And if we use it with a battery backup, electricity backup, it can be used during the non-sunny hours and also within the kitchen. And during this time also, it requires a nominal consumption of electricity. Okay, then next we have concentrating type, the concentration cooker. It actually has three broad type. First one is dish solar cooker, then we have community solar cooker, and lastly we have solar steam cooking system. So the dish solar cooker, it is fast cooking device which can be used to cook the food for 10 to 15 people under sun, and it saves up to 10 LPG cylinders per year if it is used on full extent. Okay, now community solar cooker, it is used for cooking for the people of around strength of around 40 to 45 people. Okay, and it saves cylinder up to 35 LPG cylinders per year. Then we have solar steam cooking system. It is used for cooking the food for thousands of people using steam inside the kitchen in very short time. Okay, so the steam is used for steam is generated by solar energy, and it is used for cooking the food. And it is in a, it is actually installed in the big centers, like we have installation of this system in ashrams, temples, churches, gurudwaras. Okay, so it saves quite a huge amount of LPG cylinders. Then we have the best example of solar cooking system that is installed in Shirdi. So Shirdi, it caters up to 3,000 of capacity to 3,000 of capacity of people, and it serves them daily. Okay, so the 3,000 people, they are served daily, and they are served by the use of solar steam cooking system. Okay, and the world largest system, uh, it has the capacity of 15,000 pilgrims per day. Okay, it is in Tirumala Tirupati Devasthanam. Okay, and it was installed in October 2002. The next technology that we have is solar photovoltaic technology. Solar photovoltaic technology is also known as SPV technology, and this technology, it enables direct conversion of sunlight into electricity. Okay, and here we are not required to move any part, or we are not causing any pollution. Okay, now it acts as a viable power source for the application such as lightning purpose. Okay, so for lightning purpose, water pumping and telecommunication, etc. So it is used in every such purposes. And so the solar photovoltaic cells, they are used in agriculture as well as domestic purpose, and they are also used in institutional and industrial purposes also. Now, if we rank the states according to their installed capacity, then Gujarat is ranked the topmost, having 860.4 megawatt of energy. Then we have Rajasthan, Maharashtra, Madhya Pradesh, and Andhra Pradesh in top 5. Okay. Now we have actually Ultra Mega Solar Power Program, which was launched in 29th January 2014 by Ministry of New and Renewable Energy Sources. Okay, so Ministry of New and Renewable Energy, it launched the program that is Ultra Mega Solar Power Plant. So the first, it is actually, we have four such programs, and the first program was launched in Sambhar, that is in Rajasthan. Okay, so in this area it was launched, and it is a 40,000 megawatt power project. Okay, so along with it we have three more such power projects. First one is Khargoda. Khargoda is in Gujarat. Next, we have Ladakh. Ladakh is in Jammu and Kashmir. And the fourth one is also in Jammu and Kashmir, that is in Kargil. So we have these four projects. Among them, Sambar was the first one to be established. Okay. Now, the next energy that we have is wind energy. Wind energy, it is the second most important non-conventional energy source because it is widely available source of energy, and the cost input, if we see, it is only at the initial level, and the power generation, it start immediately after the commissioning of the uh, project. Okay, so after the project is commissioned, the power generation, it starts immediately, and once the generation it starts, the power is available to us, the power is cost free. Okay, so the power, it is cost free for about 20 years, and there is no reoccurring cost on the fuel. Okay, so it is absolutely free. India, it has vast wind potential, and wind farms, they have emerged as a viable option for the advancement of wind technology in India. Okay, so the Ministry of Energy Source, Ministry of Non-Renewable Energy Source, it actually has carried out an extensive wind monitoring and mapping program in 1985, and this program was to identify the better sites and to assess the resource potential, that is the wind resource potential. Okay, now the wind potential, if we rank the states in India according to their wind potential, so the first rank goes to Gujarat, then then Andhra Pradesh, Tamil Nadu, Karnataka, then we have Maharashtra, Jammu and Kashmir, Rajasthan, and lastly we have Madhya Pradesh. These are the top 10, top 8 states according to their wind potential ranking. Okay, if we look at India's wind potential, so India's total wind potential is 1 lakh 2,778 megawatt. Okay, and this accounts for 67% of the total renewable capacity installed in India. Okay, so wind energy, it actually accounts for 67% of the total renewable energy installed in India. And India, on this basis, it actually stands fifth in the world ranking after China, USA, Germany, and Spain. These are the top four countries, and India, it stands on the fifth rank. If you look at the wind turbine, we actually have three types of wind turbine. First one is the one having horizontal axis, then we have vertical axis, and lastly we have ducted wind turbine. So these are the three types of wind turbine. Now we actually have offshore and onshore wind energy sources. Okay, now if we look at the offshore possibilities, India actually have 7,517 kilometer long coastline. Okay, and we have such a long coastline. So this coastline, it actually offers a vast wind power potential to India. And to harness this potential, India has released its offshore wind draft policy. Okay, and for this purpose, an offshore wind energy steering committee, that is OWSC, was constituted to frame the policies of for offshore wind energy development. Okay, so we are actually trying to harness our offshore wind energy sources also, and if these are also included, then India will have quite a huge amount of wind energy potential. The next non-renewable, or sorry, non-conventional energy source is biogas. Biogas, it is actually based on the use of domestic fuel, especially in rural areas. Okay, so it is based upon the dung to produce gas, which is used as domestic fuel. Okay, now this technique, if we look at this technology, this technique is actually based on decomposition of organic matter. So organic matter that are collected from the rural areas, that is cow dung or the fodders, etc. These are used as organic matter and they are decomposed. Okay, so the decomposition of organic matter in the absence of air. So this is anaerobic work is done here. Okay, so in the absence of air, the organic matter, they are decomposed, and because of it, the gases are formed. These gases are methane and carbon dioxide, which are formed in the proportion of 55% is to 45%. Okay, so methane, it is formed and it is constituting 55% of the total gas, and carbon dioxide, it constitutes 45% of the total gas. This energy is piped, or these gases are piped for the use of cooking and lightening. Okay, so it is used as a cooking fuel as well as lightening fuel in specially designed stoves and lamps. Okay, so we have specially designed stoves and lamps for using these gases, and it can also be used for replacing diesel oil in the dual fuel engine for generation of motive power and energy. Okay, so this biogas, it is used as a domestic fuel, and it can also replace diesel oil. And if you look at the other part, the leftover digested slurry, it serves as a enriching manure. Okay, so it is an enriched manure which can be used in the farmland. Okay, so the biotechnology, it takes a deep root in rural India because of certain inherent advantage. Okay, so the leftover is also quite important for the farmers. Okay, now the biogas, if you look at the biogas, it has the thermal energy which is higher than as compared to kerosene's thermal energy, then firewood, dung, and charcoal. These fuels, the thermal energy of these fuel is much lesser than the thermal energy of biogas. Okay, now if we observe the thermal energy of gobar gas, that is biogas, it is 60%, while the dung which is commonly used in villages in India for cooking, it has only 11% of the thermal efficiency. Okay, so the gobar gas fuel, it is advantageous for use. Okay, because it has quite a higher thermal efficiency, and it is also very environmental friendly. Now, the biogas technology has a bright future in India because the government of India, it is working towards the development of non-conventional energy sources. Okay, so for that, in village area, in the rural area, the biogas will be can be highly developed, and the success of the biogas technology, it will bring, or it has actually brought, a sort of brown revolution in rural India. Okay, so the biogas plant and improved chulas, they have disseminated the India since 1940s, and they have picked up the potential since then. Okay, but the main pickup, if we see, it was in early 1980s. Okay, so since 1980s, the national project of biogas development plan was launched. Okay, so this project was launched and it took off the development of biogas energy to a higher pace. Okay, this program was actually set up to provide clean and convent, convenient fuel for cooking and lighting purpose in the rural area, then to produce enriched organic manure, along with improving the sanitation and hygiene. Okay, so it's we can see that biogas, it serves all the purposes. Now we have actually have a national program for improved chulas. It was initiated in 1986 to 1987, and its objective was the fuel wood conservation, elimination of smoke or reduction of smoke, then reduction of drudgery of women and children from cooking in the smoky kitchen, and collection of fuel wood. So it wanted to reduce the involvement of the women and children in these works. So the national program for improved chulas was helpful in it. Then the another purpose was for environmental degeneration and check on the deforestation, along with the employment generation in rural areas. Okay, so improved chulas, that is the stoves from biogas plants, specially designed stove of biogas plant, they use they emit uh, very less or no smoke, and use less wood, and they are fast replacing the traditional cook stoves in the rural areas. Okay, so they are ushering the smokeless revolution in different part of the country. Okay, now if we look at the biogas potential, so we have the biogas potential in Andhra Pradesh, Bihar, Chhattisgarh, Gujarat, Haryana, Jharkhand, Rajasthan, Tamil Nadu. They are the most important states, but they are not arranged rank wise. Okay. Now, if we look at the world's largest system for cooking in the community kitchen, it is installed at Shirdi to cook food for 20,000 people per day, and it is saving actually 60,000 kilograms of LPG per year. Okay, so the 60,000 kilogram of LPG is saved in this area, that is Shirdi, and it cooks food for 20,000 people using the biogas. Next we have is small hydropower energy. Small hydropower energy, it actually is used for generation of electricity from small sized hydropower source. Okay, so it is actually low cost energy, environmental friendly and renewable source of energy. Okay, so they are easy to install, and they are installed in small streams as well. Okay, now the state wise potential ranking, if we see, we have the most potential in Himachal Pradesh. Himachal Pradesh has 531 sites, and they are utilized. Almost a quarter of them are utilized. Next, we have Karnataka. It has highest untapped potential. Okay, so the amount of potential is 3177 megawatt. Okay, so it has 3177 megawatt. Himachal Pradesh actually has 2398 megawatt. Uttarakhand on the third place, it has huge potential, untapped potential, and that is, it accounts for 1500 megawatts. After that, we have Jammu and Kashmir. It also accounts for 1500 megawatts. And the Jammu and Kashmir, it has released a policy for development of micro mini hydropower projects in 2011. Okay, so for this was actually established for it was actually this policy was actually released for the establishment of small hydropower plants. Okay. Next, we have Chhattisgarh. Chhattisgarh has untapped potential of 1100 megawatts, and the present installed energy, if we see, it is about 27 or to 30 megawatts. Okay. Then Arunachal Pradesh, it has the potential of 1300 megawatts. Okay. So these are the major states having the highest potential of small hydropower plant. Okay. The next energy that we have is geothermal energy. So there is vast possibility for developing and exploiting the geothermal energy in India, because about 340 hot spring localities they have been identified, and many of them they have actually been used. Okay. So, and many of them they are having the temperature that is near to the boiling point. Okay, so they are having quite a high temperature. Now the extensive survey they are being conducted to develop the geothermal energy for direct heat and power generation purpose. Now assessment of geothermal energy potential of states that are selected. So the selected sites they are in Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Jharkhand, Chhattisgarh. So they have been undertaken. A 5 kilowatt geothermal pilot power plant, it has been commissioned at Manikarn in Kullu district, that is of Himachal Pradesh state. Okay, and various other projects are also being conducted. Next energy sources are tidal energy source. Tidal energy source, it is having a potential of 8000 to 9000 megawatt. Okay, so India actually possesses a potential of 8000 to 9000 megawatt. The Gulf of Khambat, it is the best suited area for this energy. It has 7000 megawatt potential of tidal energy. And after that, we have Gulf of Kutch. Then next one is Sundarban. They also have quite a huge amount of uh, installed energy. Okay, so the first one is 7000 megawatt. Then Gulf of Kutch, it has 1000 megawatt. Okay, and lastly Sundarban, it has 100 megawatt of energy. A 9000 megawatt of tidal power plant, it is proposed to be set up in Gulf of Kutch. Okay, so in Gulf of Kutch we are actually going to construct or proposing a 900 megawatt of power plant. Then we have wave energy. Wave energy, it is having a potential of 40,000 megawatt. Okay, so the 40,000 megawatt energy potential is in wave energy, and the coastal areas can be specially benefited from this energy. Okay, so the coastal areas can especially be benefited from this energy, and the one of the wave power plant, it is established. It has 150 kilowatt, that is maximum energy. So it is in Vazinjam. Okay, Vazinjam, that is in Tiruvananthapuram. Okay, so here it is the energy power plant. It is situated. Okay, the another one, it is in Andaman and Nicobar Island. Okay, so it has also been set up. The other energies, if we see, they are ocean thermal energy. Ocean thermal energy, it is estimated about 50,000 megawatt. Okay, so we have 50,000 megawatt of energy capacity in ocean thermal energy. The first ever plant of ocean thermal energy conservation with the capacity of 100 megawatt, it was it is proposed to be set up in the coast of Tamil Nadu. Okay, so in Tamil Nadu coast, we are actually like estimating to set up ocean thermal energy plant. Now the next energy that we can see is energy from the waste. So the generation of waste, it is actually inevitable in many human activities. So in nature, to balance or to maintain a balance between waste generation, we are trying to generate energy from the waste products. Okay, so as we can see in nature, the balance of that balance is maintained as the waste generated by animals and human being, it actually serves as a nourishment for plant life. So the natural cycle is naturally maintained, but the huge amount of waste is generated in industries and institutions. Okay, so they are not easily decomposed by the natural cycle. So the government of India and other countries, they are trying to find a new way for using these waste for the some purposeful use. Okay, so they are trying to generate electricity from these waste products. Okay, and if we look at the potential, the mega cities and metro cities of the country, they actually they are actually a great source of waste. Okay, so the power that will be generated from this waste, they can be used for serving these mega cities and metro cities as well. Okay, so the waste will be helpful in generation of power, and this power will be utilized by these cities. Okay, and by these non-conventional energy sources, we can actually meet the demand of energy crisis that India is actually passing through. The phase that India is passing through, we can actually meet the demands of people, the energy demands of people, by accelerating the rate of improvement of these non-conventional energy sources. So that was all for today, guys. I hope you enjoyed today's lecture. Let's meet in our next class. Till then, take care and have a nice day. Thank you.